So today's lesson is all about exponents. We're going to go over the properties of exponents, and then we're going to go through my teacher notes. And I found a way that I am able to write on my teacher notes, on my blank teacher notes, so that you guys can follow along and you're not just hurriedly writing down the answers and then not listening to the words coming out of my mouth. So I found a way out to do that. Apparently it's called annotating. Go figure. Never thought it and didn't know what that meant before. But before we do that, we are going to look at this lovely set of properties. Properties of exponents. I do not believe these are all of them, but they are the majority. And I suggest that you guys write down as neatly as humanly possible your properties. I would also include examples. You can include the examples with the numbers. I think the ones you're going to see and have the most trouble with will either be the examples with the variables or the combination of examples and with variables and numbers. This first one is, they're calling it the multiplication rule. I believe I stole this from a high school. I don't know. It was online. I literally just found it. But you can call it the multiplication property. You can also call it the product rule. Essentially, it's you need to have the same base. That's what your B here is standing for. So your base has to be the same. If your base is the same, then you can add your exponents. Now, what they're not showing you here is with the numbers only, you can go ahead and evaluate that. So if you wrote down 3 to the 8th and that was your last answer, that's fine. The program will more than likely accept it. If you went ahead and you were one of the ones that chose to do this on your calculator, then you would actually find an evaluation number for that, which don't ask me what it is right now. Brain's not there. So then if you wrote down the actual number, that is also fine. I will obviously do what I normally do, which is I would either see that you had 3 to the 8th, or if you chose to write down the number and Pearson didn't like that, if I know that it's equivalent to 3 to the 8th, I would give it to you as well. The power property, it's very similar to the product rule in the sense that it's dealing with multiplication, but notice you have only one base and you're taking a power basically to a power. So you are taking the base and then you are multiplying instead of adding. So that is the difference there. Division is pretty similar to what you would think it would be. It's kind of the reverse of the multiplication property. You're taking the same base and then it's n minus m, or the numerator exponent minus the denominator exponent, which makes sense because if we turn it into a multiplication problem, b to the m would be b to the negative m. So that is why we are doing it like that. I typically do not write out the zero property, excuse me. So you guys will have it. It will not be on my teacher notes because I just kind of feel like it's one of those things that's a no-brainer. Anything to the 0 power. The largest number you can think of raised to the 0 power will be a 1. All the time, no matter what, it will be 0. And then the last one they have here is the negative exponent property. All that basically tells you is whatever position your base with the negative exponent is in, you're going to move it. You want to make it positive. A lot of times with Pearson, students will put their answer in and they'll have a negative exponent. As long as everything is correct, I will give you full credit. I'll just let you know that you had the wrong format. Pearson will give you a 0. So if you're going through and doing a problem over and over and over and over again, and 15 times later, you've just, you're to the point of wanting to hit your head on the wall, please don't do it. I suggest using a pillow. It's much softer. Then you can just either email me and let me know, hey, this particular problem, can you take a look at it for me? And or if it's on a quiz, I will probably more than likely be able to catch it before you even email me. Are there any questions regarding the properties? Because we will be working with them extensively. I might end up doing something and I might not even think about why I'm doing it. So you might have to flag me down if you don't see why I'm doing it a certain way. More than likely, I would probably just tell you it's one of our properties. Okay. I can see pretty much everyone who has their screen on, and then my lovelies who like to think that I don't see them, but it's okay. It's fine. You're fine. I just want to know, do you still need time on the properties, or can we move to the examples? Examples? Cool. All right. So I'm going to stop this screen share. I'm wondering if there's a way to like screen share from like one screen share to the next. I cannot find what I want to screen share, so give me 1 second. Oh, that's because that can go away now. Here we go. Alrighty. And now we get to do this really fun thing. Get to annotate. Makes me feel so cool. Obviously, no, I'm a college professor when I think annotating is cool. That's neat. All right, so obviously you guys have already written down your properties. So now what we're going to work on is we're going to work on some examples. And the first set we are working on will be simplifying. Now, I can tell you that you are all very lucky that you are in your homes or wherever you're at and not in a location with me, because this is the absolute chapter where before you even have done anything, I send you all to the board. Because there's so many of these, they're all basically discussing the properties that we just went over. And I just basically don't want anyone to get super bored. So I typically send you all to the board. That being the case, I'm going to give you about, what time is it? We're probably going to end up wrapping up early because it's just such a quick chapter. I'm going to give you guys about 5-ish minutes. If you guys want to work on all the problems that you see there on your own, then what we'll do is I will just write out the solutions that you guys tell me. Okay. I did find some more rules, so I guess I lied to you when I put up the teacher notes. They are just on the last page, but so let's go over these simplifying examples. Who wants to walk me through the first one? I don't care who, you can unmute yourself and just walk me through it. Obviously the beginning ones are a little bit easier than the ones we get to towards the end.
So the first one is 2 to the 5th, b to the 7th, c to the 8th, because you just add the powers.
Mm-hmm. Very good. If we wanted, if we wanted to, we're adding the powers? What do we do when it's a power to a power? Do we add?
No, multiplying, sorry.
That's all right. Don't worry about it. I just wondered why my brain didn't work with your brain. Okay.
My brain doesn't work with a lot of people's brains, so.
Hey, I always ask because you never know. If we wanted to take it a step further and evaluate, did anyone figure out what 2 to the 5th was?
I think it's 32.
It is. Very good. I would accept either answer. The program, you would have to just really read the directions. They might say that it wants it in exponential form. If that's the case, you would go with this first one. Either way, if you got the answer wrong and you really felt like, no, I feel like this should be right, just let me know. Okay, 1B, and honestly, be careful, guys, with the numbers on some of these teacher notes. I borrow them from other teachers, so I take no fault on numbering. Sometimes they just are very wacky. I think because they just steal them from the Pearson site, so I don't mind stealing from them then. All right, so what are we doing with B? What's going on with it?
So I think we have to multiply like the same numbers and add like the exponent power thingamabobs. And so the answer would be 6b to the power of 9 and c to the power of 6.
Perfect. I loved your explanation as well. I truly hope it catches on fire on YouTube. Also, guys, I have to say this. I have my first subscriber. Don't know who it is. Can't tell you who it is because YouTube doesn't let you know that kind of stuff. I kind of wish they did because I really wanted to email them and be like, thank you so much. I've been seeing 0 for so long, but I don't really care. And I also don't care that if it was one of my students because that's just awesome to me. I don't YouTube for popularity because if I did, it would be video games that I suck at. But apparently when you can do the math, you get 1 subscriber, so that's okay. I'm all right with it. I'm very, very happy. It actually made me like I just kept staring at it. I was like, yeah, that says a 1. That's awesome. But all right, it's probably some like, I don't know, third world child that was like, oh, this person has funny hair. I'll add them. Great. Now you can learn math and save your country from ruin. Okay, so number C. Letter C. 1C. What's going on with it?
I would start by simplifying the 3/12 to make that 1/4.
Mm-hmm.
And then you have b 7 minus 2, which would be b to the 5th, and then c 6 minus 5, which would be just c. So it'd be b to the 5th times c over 4.
Very good. Now, for anyone who may ask, you do not need to actually write in the little 1. If it makes you feel better, go ahead. It's not going to hurt anyone if you throw in the 1. Okay. Somebody else, somebody new. It looks like you guys are really jamming on this. I'm very excited. Somebody else do D. I know it looks scary, but just take it piece by piece and you guys got it. I'll tell you, you can do the inside first and then bring in the 4th after. I think it'll make it a little bit easier. I will definitely do some today, but I'm going to assume once you see what the second page looks like, that's going to be the one you want me to help you on. So 24 over 16 is going to reduce down to what?
I think it's
3 over
3
2.
over 2.
Very
Oh,
good.
sorry.
No, you're fine. You're all fine because you're all correct. Okay. And then, just like the previous problem, b to the 7th over b to the 2nd will give you b to the 5th. And c to the 8th over c to the 5th will give you c cubed on top. And then d cubed just stays on the bottom. It doesn't have a partner. So sad, they went stag. Okay. Now we are going to take our 4th that is outside, and what are we going to do to it?
Multiply it by like everything 4 times.
Yeah, we're going to multiply it to the exponent in each spot. Okay, so if we did it, well, I guess I'll go ahead and just do it like this, and we can just take one more step. I'll just write as small as I can. So 5 times 4 will give us b to the 20th. 3 times 4 will give us c to the 12th. And the same with d. Okay, and if we wanted to take it one more step, it would just be 81 and 16 are our coefficient numbers. Okay. All right. That is that one. Let's go with a new color. Okay. New question, new color. Let's do it like that. Why not? Okay. So number 2 only has 3 questions. The first one is super duper easy. What do we got to do? Somebody who hasn't spoken today, don't make me call on you, because I totally will. Hint, also don't turn your screen off, because I will definitely call on you. All right. Somebody new. Who can I?
Would you have to put it in like reciprocal form to find the reciprocal of it?
Kind of. So right now the b to the -7 is up top. So when you say reciprocal form, we're still going to keep the 9 up top because it has a positive exponent. We are going to bring that b to the 7th down below so it can be a positive exponent. Okay? Very good. That makes this one pretty much also just as easy. If we have b to the negative 3 on the bottom, somebody new, tell me where it's going to go.
We're gonna move it to the top. So 5b to the 3rd.
Excellent. Now, I will tell you guys, if you haven't already taken a look at your homeworks for this, like if you got your exam done early and you wanted to take a look at chapter 4. If you have not already taken a look at chapter 4, Pearson loves to give you guys problems where it looks like crazy, crazy big, and then you guys are looking at it like, I don't know what to do here. Literally take it one small piece at a time, make them into as many smaller problems as you need to make them into. And remember, if anything's raised to the 0 power, no matter how scary or funky looking it looks inside the parentheses, if it's raised to a 0, it's just going to be 1. Okay, so 3 to the negative 1 plus 4 to the negative 1. What are we going to get there?
I got 7/12.
Perfect. I'm going to assume that you do not need that worked out then. Excellent. All right. I'm also going to assume that everyone is copying things down as needed, so I can just go ahead and scroll. Oh, sugar plum. Oh, that's obnoxious. And I can't just hit clear. I bet I just can't hit clear because I do not want to sit here and reopen it, so I'm not going to. Instead, I'll just do this crazy fast, and I feel that's like where real YouTubers can be like, and it's gone in 2 seconds. But it's not. Okay. So there's a caveat that I want to talk to you guys about, but I guess now is as good a time as ever. Wonder if there's room anywhere else though before we get to these. There is. There's a little bit of room right here. So before we do anything else, does anyone know the definition of the word caveat? Who's my Englishy people in here? I think I copied that right from Google. Okay, so our caveat is I want you to tell me the difference between this and this. I want all of you to discuss it. Tell me about it. Tell me what you see is different.
The way I see it is the second one is 3 times b squared, and the first one is 3 times b. All of that together is squared.
Correct. So then your overall solution here would be 9b squared. Okay, it may seem like a simple little thing that we're looking at there, but if you don't allow your mind to look at that and kind of see that difference, that those parentheses are so strong and they have such a meaning behind them, there's a chance that later on when you get to a bigger problem that you might, definitely not remember that. So very good. Definitely glad that you guys could see that so easily. Thank you. Okay. All right, well, let's go up and get some more problems done. Okay, let's go with orange. Okay. Did you guys overall like having a few minutes to work on it by yourselves? Or did you prefer to just going through it? You guys let me know. If you like working on it by yourself, I can give you a few minutes. Either way, it doesn't matter. Okay. All right, well, let's go ahead and keep going then, because we do have some heftier ones to get through. I actually thought there were some more problems. I guess not. I just saw words and thought they were problems. Okay. All right, so for this one, before you can go through and simplify, you actually do have to do the parentheses first, because you have parentheses on top and bottom. So 3 squared will give you 9. B to the first squared is just b to the second, or b squared. C to the fifth squared is c to the 10th. Okay. 2 cubed is 8. B to the -2 will give me b to the -6th. And then c squared times 3 will give us c to the 6th. Now, you could ask me, could I just move my b to the -2 up in the beginning? And my answer to you is that you cannot, because you would have forgotten to move the cubed. Now, if you would have realized that you could move b squared cubed up, then yes, you could have moved it up at the beginning. I don't recommend it, so that you can have all of your pieces. Okay, the 9/8 is going to stay the same. When you move your b to the 6 up, what happens to b squared and b to the 6? What do they become? What do you guys think?
It would just become b8, right?
B to the 8th, very good. And when we're dealing with exponents, whoever has the higher exponent, that's the position that it keeps. So c to the 10th over c to the 6th, we're just going to subtract them. We get c to the 4th. Okay. And that answer is done. Now, with the next one, you're dealing with a lot of negative exponents. You have 2 options here. You could choose to bring the -4th into each piece. I'm not recommending that. I would recommend doing everything inside, simplifying as much as possible, and then bringing in the -4th. However, you're all adults. As long as you follow the rules of math, you may do whatever you wish. 18 divided by 6 is going to give us a 3. B to the -4th and b to the -3rd. If we work those out, we're going to end up getting b to the -4th minus a -3, which is going to give us b to the -4th plus 3. So b to the -1. And then c to the 7th over c squared is c to the 5th. everything raised to the negative 4. Okay. Now, because you guys seem to be getting the handle on all of this, I am just going to skip a couple steps. 3 to the negative 4th, we're going to move it to the bottom, so it'll be 3 to the 4th. 3 to the 4th is 81. B to the negative 1 raised to the negative 4. Negative times the negative gives us positive, so B to the 4th is going to be on top. C to the 5th times negative 4 will give us C to the negative 20th, which means it's joining 81 on the bottom. Okay. That is your overall answer there. Any questions on that? No? Okay. Hoping everyone has it. If not, obviously this is being recorded for my very large population on YouTube. I'm sure they will vastly love learning about exponents as much as you guys have. Okay. Oh, new problem, new color. Let's go with my favorite. Okay. So number 4 is just working with functions in the sense that I say just because you're literally just going to plug it in. More likely than not, the program will want you to evaluate as long as you can evaluate. So here is our...
We're at where it says boys must be told.
Sorry.
You're okay. Make sure you pay attention here. We have f of x and we have also g of x. And clearly with the C and D, we are not going to be able to work out a complete answer there. You will not be able to evaluate it. So for A, we want f of 3. So that means 3 is going to go in place of the exponent. So you will have 3 times 2 raised to the 3rd, which is basically 3 times 8, which gives you 24. Okay. F to the negative 4th, I guess in this case we will write different colors for each letter. Okay, B to the negative 4th is just going to be 3, 2 raised to the negative 4th. Now, those parentheses are important because that negative 4 is only with the 2. The 3 is going to remain on top. Okay, and 2 to the 4th is 16. And you cannot reduce that. I do apologize, the letters are no longer matching up. Okay, so G is going to be 5 raised to the A plus 3. That is an A, not a 9. Don't confuse it. I'll make it a capital, I guess. Now it's just looking kind of rough. There's an A to the plus 3 up there. Now, what that means is we can actually use our property rules and realize that that means 5A times 5 cubed. Well, now we can figure out 5 cubed. 5 cubed is 125. So it's 125 times 5 raised to the A. Okay, that is your entire complete answer. It would be technically equivalent if you left it in the other forms, but then I would still have to take off partial credit and tell you it's in the wrong form. Okay, now we want to do g of 2a, so that's going to be 5 2a in the exponent spot. Now thinking about what we just did, we used our property rules. So which property has us multiplying the exponents? You can go back and look at your property examples if you need to. But which one has us multiplying our exponents?
The power property or the multiplication property, either one of those two.
Okay, it's going to be the power of the power. Great job. Okay, so that means we're going to keep 5 squared inside. You're going to bring in parentheses, and you're going to take a to the outside exponent. Now 5 squared, we can go ahead and evaluate. That's going to be 25. So it's 25 to the power of a. Very good. Let's use ugly brown for scientific notation because I dislike it so much. Okay, here's your quick math pro tip of the day. And hopefully I will say it right and we will not end up being confused. If we have a positive k, and in this case, k is your exponent. If it is positive, we are going to move that many spaces to the right. If it is a negative k, we will move that many places to the left. Okay? So 3.462 times 10 to the 5th. It is a positive exponent, so we are going to move the little decimal pieces to the right. However, we only have 3 numbers, so we're going to use zeros as placeholders. 1, 2, 3, 2, 3, 1, 2. Okay. Now, I believe a student did an experiment with me, and Pearson does not care about commas. When it's an answer like this, you can either write it out with the comma or you can write it out without the comma. Either way, I guess it accepts it. I don't really know. I would probably not use them unless you are having an issue with seeing the right number of zeros. Okay, the next one is 7.38 times 10 to the negative 4th. So we are going to move to the left 4 spaces. We only have 1 number, so we need 3 0 placeholders, including, in addition to the original 0 for out here. Now, I can tell you this will not be written in scientific notation, because scientific notation you must have a number in the front, not just a 0. Okay. For number 6, we are going to practice writing in decimal notation. This is typically where I start to have some issues with my dyslexic moments, but thankfully I've written it all down, so I should be fine. Times 10. Okay, so we have a really large number there, and I want to make it 6.257 times 10 to something. Is that something going to be positive, or is that something going to be negative? Somebody tell me.
It'll be positive.
Very good. It's actually going to be a positive 9. Okay. Okay. We have a very small number. We are now choosing to make it 7.21, so it's a much larger number now. Therefore, this is going to be a -6. Now, to get your numbers, all you simply do is count up your zeros, count up any extra numbers that you had in place of things, and that's how you get your exponents. Not really too harsh on that. Okay. Any questions up to that point? Any questions on filling in for functions, on evaluating when you have to evaluate, on understanding that if you get to a certain point, I'm probably going to give you credit, but Pearson will probably not? And then any questions on scientific notation? Okay. If you have any issues with any of that, Google is a fabulous tool. YouTube is a fabulous tool. Obviously, and my lovely lecture for you today will be on YouTube later. Okay. Oh, this is so neat. Apparently, oh no, it's not. That's weird. I thought that the eraser was erasing in the color that I was also writing in, but it's not. It's blue for some reason. Okay. So now we are going to work on a little bit different of simplifying. This is simplifying with a fraction in the exponent spot. Do not let it scare you. It simply means that anytime you see a fractional exponent, you're going to go into what's called radicals, okay? So the first one, if it's 25 to the 1/2, you're simply going to rewrite that as the square root of 25, which is what?
5.
Yes. To be concise, it is actually plus or minus 5, because not only is 5 times 5 25, but also -5 times -5 is 25. Now, Pearson will accept just 5. I will tell you that this is the one spot where Pearson is a little bit nicer than Mr. J. If you take an exam for Mr. J and not for Pearson, and you only give me 5, I will let you go the first time, but then if I see it repeatedly, eventually I'm going to start taking points off, because I will tell you, square roots, even roots are a plus or minus. Odd roots, the sign is very important. Can anyone tell me why? Why do you think it would be important for an odd root?
Is it because it's a non-real answer?
Not exactly. So with square roots and even roots, you have an even number of terms that you're using, correct? So 5 times 5, right? Square root 5 times 5. Positive times a positive, negative times a negative, they both yield a positive. But with odd roots, if you have a negative number with an odd root, you have a negative outcome every time. Negative times a negative, positive times another negative, positive times a negative is negative. You will have to have your signs matching up. So that leads us to 64 to 1/3 would be the cubed root of 64. And that answer is what?
+4.
Very good. Okay. You cannot say that it is plus or minus 4 there because -4 to the cubed root or to the cubed power will be a -64, not a positive. Okay. C. C you can do because it's an odd root. So that's just going to be -4. These get very, very tricky, so definitely pay attention. D is going to be the 4th root of 16, which is 2. Now the next two, look at the positioning, okay? There is a parenthesis set in the last problem. There is not a parenthesis in E, which means we can do a negative on the outside and just basically redo the problem we just did. So we end up with a -2. However, is there a number that will allow you to multiply it by itself 4 times and yield a negative? Think about it. I can tell you that technically, once you get to college algebra and maybe definitely college algebra, I would think, your answer here would be 2i. Okay. For the sake of your world, it is a non-real solution. Okay. I is equal to the square root of -1. Okay. Any questions to that point? Do you guys feel like you have an okay handle on fractional exponents?
I have a question about that first page. Will you put, where's that like finding the exponent thing, like the definitions for like properties of exponents?
I can put one. Well, they're on my teacher notes, but I can put one up on Canvas.
All right, thank you.
You like the one that had examples?
Yeah, I just liked it to reference to kind of look back when I'm stuck and kind of look at that to help me out.
Sure. Yeah, I'll find it. Okay. Any other questions with this set? Okay. What I do want you to take a quick look at before I erase anything, notice that all of these exponents had a 1 in the numerator. And the denominator is what went into the root. Okay. So in the next part, I want you to keep that in mind because that is where the denominator goes into the root and the numerator stays inside with the number. Okay. Gonna get rid of all this. And we can move on to the last page. Woo! All right. It's kind of tight in here. So I think I'm gonna write some stuff up in the margin if I can. So f of 2/3. Here is our f function. Here's our g function. Here's our h function. F of 2/3. So that means we're gonna do what? Somebody walk me through it. I feel like I've been talking a lot.
Would you just plug in your f of x for your first problem into the 2 of 3?
Right, so we're gonna take 64 and we're gonna raise it to the 2/3 power. But that's a fractional exponent, so I can still figure it out. We have, what we basically have here is we have 64 to the 1/3 squared. So the cubed root of 64, that answer, squared. Well, the cubed root of 64 is 4. So 4 squared is 16. You could have put that in your calculator. I'm not going to stop you if that's the way you want to do it. Just make sure you use your parentheses correctly. So 64 caret parentheses 2/3 parentheses should give you 16. Okay. Same thing with B, except you have a 3 outside. So 3, 16 raised to the 3/4. I'm just going to write down and then we'll erase to do 15, 16, and 17. So it's going to be 3 on the outside still, 4th root of 16, and that answer cubed. Okay. So we found the 4th root of 16 to be 2. So 3 times 2 cubed. 3 times 8. 8 equals 24. All right. And then the last one, let's kind of go up with it. Go up that way. H to the -1/2. So -5 outside. 9 raised to the -1/2. Well, what does negative in the exponent make me do? Where am I going to go?
Left.
Not left, but remember right now we're on top, so we're going to go where, Teddy?
To the right then.
If we're on top, we're going to go to the, what's
Down.
the opposite of top?
Down.
Yeah, we're going to go to the bottom. Very good. Okay. So it's going to be the square root of 9, but it's on the bottom. So then your overall answer there is -5/3. Now, why can it not be my traditional plus or minus 3 in this case? Somebody tell me. Tell me why it has to be a positive. What do you know about your 5?
It's negative.
The 5's negative. If I put down my plus or minus 3 there, a minus and a minus makes that answer positive, right? Do I want a positive answer here? No, I want to keep it negative. So it does have to stay as the positive in this case. So just be careful when you give me my plus or minus. Now, I can tell you that if you do put the plus or minus A in Pearson, it will give it to you as a correct statement, okay? You are allowed to do it, but not in this situation. In this situation, you have to keep it negative. All right. Any questions on these three before we move on to the last three? Wow, can you believe that? We might be done maybe 5 minutes early. I guess I like talking to you guys. Okay. I can tell you the last one is a lot of steps. But you guys seem to catch on to this pretty quick. So might not need to do as many steps with everyone. Okay. The last set of problems. I liked the orange. Let's finish up with the orange. And we're gonna need a little bit more room, so. Okay. B to the 2/3 times B to the 1/2. Now, don't go getting all kinds of crazy with, well, we got to do a cubed root and a square root and everything. And ideally, what you want to do with these problems is make it so that they are the most simplistic that they can be. So, when they're multiplied like this, that means we can do what with the exponents? Multiplication goes with, tell me what it goes with.
Don't you just add them?
Very good. We are going to add them. So 2/3 plus 1/2. Now, I'm writing kind of big, but you guys still write them as exponents. Okay. So we want to get them to have the same denominator. So we're going to choose a 6. So that'll be 4/6 plus 3/6 will give us B raised to 7/6. And that's it. That's that one. Ow. All right. Now, I don't know why I chose to bring a negative exponent into this one. It's negative on my paper. You can choose to ignore that. I would just go with it the way we're going to do it here. So 32 is going to stay the same. We're going to leave that as a 32. We are going to combine the b's. So which b is bigger, b to the 12th or b squared? Right, b to the 12th. So since b to the 12th is bigger, we're just going to do 12 minus 2 will give us b to the 10th. It just happens to stay on the bottom. And we're going to raise everything to 2/5. Now, we're going to bring that 2/5 in. So, we're going to have the 5th root of 32, that whole thing squared. Now, to do the bottom, you multiply them. So it's going to be b to the 10th times 2/5. The fifth root of 32 is just 2. And then 2 squared is just going to be 4. B times, 10 times 2 will give you 20. 20 divided by 5 is 4. So it's going to be b to the 4th. And that's it for that one. Okay. Now, for the last one, there's an assumption we have to make. What do you think that assumption is? I told you guys there was a difference with signs earlier between even roots and odd roots. So what do you think B and C have to be in order?
Positive?
Very good. So not that Pearson will require it, but if you are doing a problem like this on an exam for me, I need to see that statement, okay? And even if, let's say you're doing a problem like that for me and you're not sure if that statement should be there or not, it's probably better to just write it down. I'll probably end up giving you bonus points for it. Okay. 81 to the 1/2 is 81 square, or square root of 81. B to the 6th divided by 2. C to the 20th divided by 2. All over the cubed root of 27 squared times b to the 12th times 2/3 times c to the 9th times 2/3. Okay. Square root of 81 is technically plus or minus 9. We're just going to go with 9. C to the 6/2 is just c cubed. And, oh, sorry, not C. I apologize. I must be getting tired. Good thing it's last problem, guys. And then c to the 20th/2 is just c to the 10th. All right, to the bottom. The cubed root of 27 is 3. And we're going to square it. B to the 12th times 2/3, 24. 12 times 2 is 24 divided by 3 gives us c to the 8th. But since we already have to do one more step, we'll just write it in there. Oh my goodness, I did it again. I called BC for the 8th time in this problem. Apologies. All right, and then c to the 9 times 2/3, that's gonna give us 18/3. And then now all we have to do is go through and clean it up. 9 and 3 squared, how are they related? They are
They're the same.
They're the same, so they're gonna cancel. All right, so then we're gonna have b cubed over b to the 8th c to the 10th over c to the 6th. And I'm just going to cancel those out so you know they cancel. 8 is bigger than 3, so 8 minus 3 will give us b to the 5th on the bottom. 10 is bigger than 6, so 10 minus 6 will give us c to the 4th on the top. All right, that was super duper long, but does anyone have any questions? Nope. I will make sure that the chapter 4 notes are placed onto Canvas. I will also go ahead and make the YouTube video of this, and anyone who has turned in your exams, I will go ahead and do the gradings for that.